In this video, we will solve a problem on price discrimination in case of monopoly. The question is, a monopolist sells his output in two distinct markets between which price discrimination is possible. His total cost curve and two demand curves are being given as his. Total cost is equal to 8q plus 100, where q denotes the output, and market demand function is being given as q1 is equal to 10 minus 0.5 p1. q1 is the quantity demanded in the first market, and p1 denotes the price in the first market. In the second market, we have q2 is equal to 40 minus p2. Okay, we have to calculate the profit maximizing price in first market, price in second market, quantity in first market, and quantity in second market. Okay, so what we are being given here, we are being given, let's take the first market here. Okay, for first market, this is our demand function. So our, let me write it here. So demand function is being given us as q1 is equal to 10 minus 0.5 p1. Let us first find out the inverse demand function. That means we solve it for p1. So this is 0.5 p1. If I transpose it here, it will become positive. It becomes 10 minus q. 0.5 means 1 upon 2. So I can write p1 is equal to 10 upon 0.5. If I transpose this 0.5, it will get divided to each of these terms. So 10 upon 0.5, it will become 20 minus 2q. This is our market demand function in the first market. Okay, and what is the total cost being given us? Total cost is being given us as total cost, or let me use another color. Total cost is being given us as 8q1 plus 100. Okay, profit maximization requires, as we know, or let's write it here. So profit maximization requires that marginal revenue in the first market should be equal to the marginal cost. That means we need to calculate the marginal revenue. This is our inverse demand function. First, our total revenue in the first market will be equal to price into output of the first market. So price function is this 20 minus 2 q1. To this we multiply q1. Okay, so this becomes 20 q1 minus 2 q1 square. Our marginal revenue in the first market will be the derivative of total revenue function with respect to q1. Okay, so taking derivative of this total revenue function with respect to q1, derivative of q1 is 1 here, so we will get 20 minus derivative of q1 square is 2q. So 2 into 2 is 4 q1. Okay, marginal cost, let's calculate the marginal cost also. Marginal cost is simply the derivative of total cost function with respect to q1. Okay, so that means our marginal cost will be equal to total cost function is this, its derivative will be equal to the derivative of q1 will be equal to only 1, so we will be left here with 8. Okay, now here one thing that's to be noted, this q denotes q1 plus q2. Okay, that means in reality our total cost function would have been 8 times q1 plus q2 plus 100. Okay, so that's total cost will be 8 q1 plus 8 q2 plus 100, which means our marginal cost will be the derivative of total cost function with respect to q1. That's marginal cost in the first market. That is the derivative of q1 is here 1, so we are left with 1 here, so we will be left with only 8. Okay, derivative of this will be constant. Sorry, this will be treated as constant because we are taking the partial derivative with respect to q1, and obviously this is the constant term, its derivative will be equal to 0. Okay, so equating marginal revenue with marginal cost, marginal revenue we got 20 minus 4 q1, we equated with the marginal cost. Marginal cost we got 8, solving for q1. So 4 q1 will be equal to 20 minus 8 is 12. That gives us q1 will be equal to 12 upon 4, that is 3. That means output that the monopolist will produce in the first market will be equal to 3. Corresponding to this, what will be the price? Simply put the value of Q1 in this inverse demand function to get the equilibrium price in the first market. So we have 20 minus 2 times the value of Q1, we got here 3, which comes out to be 20 minus 6, which comes out to be 14. Okay, now for second market you can go with the same synergy, that is total demand function in the market 2 is Q2 is equal to 40 minus P2. Solving for P2 to get the inverse demand function, we will get 40 minus Q2. Total revenue in the second market will be equal to price into output, that is P2 into Q2. So P2 is this 40 minus Q2. To this we multiply Q2. This becomes total revenue in the second market will be equal to 40 Q2 minus Q2 square, and marginal revenue in the second market will be the derivative of total revenue function in market second with respect to Q2. Taking derivative of this function with respect to Q2, we will be left with only 40 here, because the derivative of Q2 will be 1 here. Derivative of Q2 square is 2Q2, so we will get here 2Q2. Okay, this is our marginal revenue in the second market. And marginal cost, if this is our total cost function, so marginal cost in the second market will be the derivative of this function, partial derivative with respect to Q2. So derivative of first term will be 0, no Q2 is involved, and we have the last constant term. The derivative of first and last term will be 0. Here the derivative of Q2 is 1, so again we get the marginal cost is 8. Okay, equating marginal revenue with marginal cost, that means 40 minus 2Q2 will be equal to 8. Solving, we will get 2Q2 is equal to 14 minus 8 comes out to be 32, I guess. Yes, that means Q2 will be equal to 32 upon 2, which comes out to be 16. So quantity produced in the second market will be 16. And what will be the price in the second market? Just plug, or let me write it here, P2 will be equal to, this is our inverse demand function, plug the value of equilibrium quantity in this function, so 40 minus 16, which comes out to be daha yaşadık. Okay, 3 artı, that means 24. So what actually we got, the price in the first market is 14, will be 14 for profit maximization, and quantity in the first market, we got it somewhere. Okay, yes, that is 3, and price in second market, which we got here 24, and quantity in the second market we got is 16. Okay,